Right now, the blood moon lunar eclipse is underway. It is not visible to us in the U.S., but to others around the globe, including millions in Africa and Europe who are getting a chance to see this. CBS News foreign correspondent Debora Patta spoke with astrophysicist Andrew Chen on the historical significance of the total lunar eclipse.
This is something that I think people take for granted, but through a lot of important work, scientists now understand exactly why we have lunar eclipses, solar eclipses, all these phenomena where we know exactly how big the Earth is, how far away it is from the moon, how far the sun is, what the orbits are. It all is due to Newton's law of gravitation. And so we can predict exactly when things happen. In ancient times, before people understood any of this, and they sort of worshipped celestial bodies and all those kinds of things, events like this, where they had no idea why they're happening, were terrifying.
The Earth would go dark.
Yes, exactly. And seeing the moon turn blood red and not knowing why, that's something quite extraordinary. And so now I think people are a little bit blasé about it, but we can step back and think, we know exactly why this is happening. We know so much about the universe that we didn't know before, and it's because of this accumulation of knowledge that we've had, and it's something to treasure.
And for more on the total lunar eclipse, we're joined again by CBS News foreign correspondent Debora Patta from the Johannesburg Planetarium. Debora, what else did Dr. Chen say about why the blood moon gets its red color?
Well, that, of course, is the most exciting part of the evening, that blood moon. That should happen, not too long from now. In fact, it's still not quite there yet. But effectively, as the moon passes through the Earth's atmosphere, the shadow of the Earth's atmosphere is cast onto the moon, and the sun is reflected through that. So think of it as the Earth is exactly between the moon and the sun, and those red lights, which are the longest waves, is what causes the light, because the blue and the violet ones are quite short. So it's much like a sunset, and that's what you're seeing. That color could, of course, be affected by pollution and debris, so some parts of the world it won't be as bright, but here in South Africa today we have very clear skies in Johannesburg, so I think everyone is hoping that it's going to take on that beautiful glow a little bit later from now.
It's very exciting. You are exactly where you want to be to see it so well. Debora, what is unique about this particular eclipse?
Well, a number of things, in fact. I think it's a real treat for those who love things about the stars and space. Tonight's lunar eclipse, a total lunar eclipse, is the longest one of this century. So it will be 1 hour and 43 minutes that it will occur, the entire event. And one that long will not happen for another over 100 years. So we won't be around to see the next total lunar eclipse that is that long. There will be other ones this year, but they will be a lot shorter. What you will also see tonight is Mars is the closest to the Earth that it has been in 15 years. So we can see this big bright moon right now, and a very unscientific term, a little orange blob next to it, that's Mars, which we're going to see. And when it goes into total darkness tonight, when that total lunar eclipse takes place, there is also going to possibly be a meteor shower, so we may actually see some shooting stars. So a lot lighting up the skies tonight here in Africa.
And Debora, what does the scene look like around you now? Can you describe the excitement there? Who is out looking at the stars?
Well, what we have are students from the university and just people from the public. They've been invited. They're being treated right now to a show, a film, and a talk about what's going to happen. And any minute from now, they'll be coming outside. The telescopes have all been set up, so they'll be able to watch really closely. Obviously, it's great if you have a telescope, but a naked eye does just as well, and you don't need any special equipment. You don't need glasses. There's no danger. What we can see right now is just the bright moon. It hasn't turned that red color yet, but as people gather outside in about an hour from now, it should be at its peak red color, and then it will go into total darkness. Tanya?
And is there a lot of excitement there in Johannesburg? Would you say that everyone in the city is standing by watching this?
I wouldn't say everybody, but certainly there is a lot of excitement. And if people haven't actually come to the planetarium or to the observatory in Johannesburg, they can even see it from their own home. There are a lot of viewing sites that have been set up, people going to sort of high peaks to see what's going on. So there certainly is a lot of excitement, and for young children as well. This is something, you know, they've only ever learnt about at school. Tonight they'll actually be able to see it with their naked eye, something that, you know, as I said, won't happen for another 100 years. And because we know, because we can predict, as Andrew Chen was saying, when it's going to happen, everybody can prepare for it. In ancient times, this was a calamity. When they saw a blood moon, it meant something terrible. The Incas believed that the jaguar was eating the moon, and in ancient Mesopotamia, they believed it was a direct attack on the king. So they put a proxy king at the time of a possible lunar eclipse. Today it's just excitement, no bad omens here at all in South Africa, just a lot of enthusiasm and the hopes that we're going to see something great later on.
Absolutely. Debora Patta, thank you so much. We'll check in with you a little bit later. Joining me now from Boston to discuss this cosmic phenomenon is Amanda Bosh. She's an astronomer and planetary scientist from MIT. Amanda, welcome. It's a pleasure to have you join us. So tell us what exactly is happening right now between the moon, the sun, and the Earth.
Yeah, thank you very much. I appreciate having this opportunity, and I especially appreciate having the opportunity to see the images from South Africa, since over here in Boston we are not seeing the eclipse. So what's happening is we have the sun, the Earth, and the moon in a line. And so basically the sun is shining on the Earth, and then the Earth is casting a shadow, and then the moon is within that shadow. And so that's the moon right now is starting to enter into what's called the umbral phase. So it's entering into the Earth, the total shadow portion of of this particular eclipse. Prior to this, it was in that penumbral phase, which you can see on the screen now with the blue area there. And from that, you only see a slight dimming. It's not very obvious. But when it enters this umbral part, the full shadow part, that's when basically all of the light that is falling on the moon from the sun will be extinguished. And then the only thing that will be left that we will see will be this potentially this faint red color that is basically sunlight that is filtered through the Earth's atmosphere and then goes on to then reflect off of the moon.
But the moon will never be completely blacked out, is that correct?
That's a really good question, and the short answer is no. It will never go completely away, but depending upon the amount of dust and aerosols in the Earth's atmosphere, it could get very, very dark, or it might not be very dark. And so it's a little bit difficult to predict ahead of time. And so we're just going to wait and see what it looks like. So if there's been a volcanic eruption recently, then we'll see, then the moon will be darker and it'll be redder, because those small volcanic ash particles in the atmosphere will filter out the bluer wavelengths of light, allowing only the red light to continue on to the moon. So that might be what happens here. It's
so interesting. So that is the only element then of surprise, perhaps, correct? I mean, scientists know exactly when this is going to happen, how long it's going to last, and when it will happen again, correct?
That's right. You have it exactly right. And so we're just waiting to see, exactly how dark it's going to get and how red it's going to get. I know we've been having a lot of forest fires in the western U.S. and really around the globe, and that throws up ash into the into the atmosphere, so that can affect the color that we see on the moon during this eclipse as well.
Is there any, there's been so many, like you said, fires, and there's a heat wave right now. Does anything coming from the planet in terms of weather affect this?
You mean from the Earth onto the moon? Yeah. Basically, it's just in the phase of totality, when the moon is completely, within the Earth's shadow. It's just that's the only time when weather on the Earth is going to affect what the lunar eclipse looks like, because the sunlight is being filtered through our atmosphere.
And since the Earth is blocking the sun from the moon, what is happening on the surface of the moon?
Oh, that's a really good question, because the moon doesn't have an atmosphere of its own. And so it actually has very large temperature shifts between night and day. So it can change temperature by about 300 degrees Fahrenheit. And so what's going to happen on the surface of the moon here is as it enters the Earth's shadow and then it loses that heating from the sun, the temperature on the forward-facing, the part of the moon that we're seeing, is going to suddenly drop by potentially up to the 300 degrees. And that actually, if you observe the moon during an eclipse, that can actually tell you something about the properties of the rocks on the surface of the moon. Basically, it's something called thermal emissivity, so how much it holds on to heat. And it'll be different in different portions of the moon.
It's so interesting. So if we were standing on the moon's surface, Amanda, and we were looking up, towards Earth, I guess, because Earth would be between the moon and the sun, what would the event look like from the surface of the moon?
Right. So now, that's a great question. So now if we take ourselves off of the Earth and put ourselves onto the moon and say, okay, what do we see? So we can imagine a hypothetical astronaut in a moon base, on the surface of the moon, and our astronaut, she would walk outside of her moon base and look in her full gear and look up, and what she would see is the sun blazing in the sky, and then slowly the sun would start to be blocked by the Earth. And so from the surface of the moon, our astronaut is actually seeing a solar eclipse. And after the Earth is fully covering the moon, then our astronaut, she could look up, and then she would be able to see lights from the cities on the dark side of the Earth. Right. And then, I know, wouldn't that be really neat?
It would.
So it's something we can look ahead to when we have hopefully, when we have a moon base.
So would it be sort of, a dark spot and then sort of light from the sun around that dark spot?
Exactly, because the Earth's atmosphere would then be filtering the sunlight around. And so we would see a dark area with a red ring around it.
Oh, how pretty. Well, maybe in the next 100 years, is that when the next one is supposed to happen? Is that right? 100 years or so?
Well, actually, that's the next one that's about the same length.
Okay.
The next total lunar eclipse is actually going to be January 21st of this next year.
Which will be a shorter one, though, right?
It'll be a little bit shorter. It'll be 1 hour, 2 minutes. Instead of this one is 1 hour, 42 minutes. Still will be a really spectacular thing to see. And it will be visible all the way throughout North America and South America.
Great. So we'll get our turn.
Exactly.
Amanda Bosh, thank you so much for your insight.
Thank you.